Hello, this is another C++ video. We're going to be doing Chapter 5 in this video with Gaddis's early objects, starting out with C++. Chapter 5 is about looping. We will talk about the while statement, which is one of the loops that you can do, incrementing, decrementing, and the different uses for a while statement. There are several. One of them is for just to count through something, but of course you could do input validation. You could do several other things with like sentinels and other, which are quite interesting. We'll also talk about the for loop, which is a different type of loop, but same idea. And there's nested loops and breaking out of loops and some file data. So essentially there's three major sections, which is the while loop, the for loop, and files. Okay. We're now going to go to C++, Visual Studio, and see what we can do. Okay, so here is Visual Studio. We are on Chapter 5. Starting out with early objects, C++, 9th edition. I have my include statements in here, and I have my using namespace, which is also a requirement, and I have my main. Main is the major function where everything is. Now, I'm going to be running a couple programs. I have some things down here, which I'll show you afterwards. But for now, I'm going to be using a while statement. So let's just count something. So I'm going to say int counter equals 1. And I'm going to now say while counter is less than or equal to 5. So as long as counter is less than or equal to 5, it's going to continue to do whatever it's supposed to do, which in this case is just going to say hello. Sorry, hello, very excitedly, \n. So it's going to do this many times. So just like a for loop has the brackets and it would only process the thing immediately afterwards, this does as well. So for instance, it would say it 5 times. If, however, I had something like this, hello, Bob and Alice, right? If I had something like this, this would say while counter is less than or equal to 5, hello, 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 hello. Now, it actually never stops because I never told counter to move. Counter is just less than 5. It's always true. It's a true statement. Counter is less than 5. So that's always going to be true. But cout hello is going to happen again and again and again. But the cout Bob and Alice is never going to happen. Why not? Because it's not in the brackets. It only does the thing immediately afterwards. If you keep it in the brackets, then just like the for loop, the if statement, Bob and Alice are going to happen together. Now, the only thing is, it's going to say, hello, Bob and Alice. The thing is, though, that I have to also increment counter. Now, this is the way that plus equals that you could increment counter. Make it go up by 1. So while counter is less than 5, we're going to say, hello, Bob and Alice, and it's going to get counter is going to increment. At some point, counter is going to hit 5, and then counter is going to be less than or equal to 5, yes, but then it's going to hit 6. It's going to check this condition. It will not be true, so it's going to stop. So let's just make this equal to 10. And I'm going to debug and run this, start without debugging, and see that my program says, it's going to start soon. I'm just trying to fill in some music here. Oh, there were build errors. We'd like to continue with the rest of the last build. No. Let's see what my build errors were. Return 0. Where do I have any errors? I don't have any errors. Prime testing. Oh, because I have other programs down here that are whatever. I have other programs down there. So somewhere in here, it's messed up. What I wrote over here is perfectly fine, though, so I'm going to just ignore that. But I'll get to that later. So this will say, hello, counter is less than or equal to 10, and it's going to say, hello, Bob and Alice, hello, Bob and Alice, hello, Bob and Alice, hello, Bob and Alice 10 times, and each time counter is going to increment. Because we have this incrementer here, counter is going to be incrementing, and it's going to be doing that. I'm going to disappear myself for a minute. Whoop. And we have that. So now that's just for regular while loop. It's a loop. Now there's two things a computer can do really well. One is that it can do logic, if statements and switch statements. The second thing is it can do loops. Looping is it's something repetitive, iteration. Okay, it can do that very, very easily. So now we're going to do for some input validation. Okay, so instead of saying if, I'm going to use this. So I'm going to say int players, and I'm going to say cin greater than players. The user will tell me what that is. Okay, and now I'm going to say while players, okay, is less than or equal to 0. What am I going to do? I'm going to say you have to pick something. Let me make that. There's no end line necessarily there. But while players is less than or equal to 0, what do I want to do? I want to say cout invalid number of players. Okay, cout invalid number of players, and I'm going to ask you again. I'm going to say please input number of players \n, and now cin players. Okay, so what I did over here is I basically said that I want you to input number of players. Now cin players. While players is less than 0, if for whatever reason you were saying that it's less than or equal to 0, you put -5, the invalid number of players, please input it again. This is going to continue forever until that condition is not true. So as long as it's going to ask again for cin players, and if players is greater than 1 or 0, greater than or equal to 0, it's going to say if the while loop is done, because then this will be false. But if players is less than 0, because you're putting invalid data, it's going to ask you again and again and again and again and again what to do about players. And so this is an example of a while loop being for input validation. First, we just did it with a regular counter doing a loop. This is to validate your input and say, ooh, players is going to be the right size. Okay. Now, just a word that we should be aware of. There's different ways to increment something. If I say int num equals 1, I could say num equals num plus 1. That would add 1 to num, so it's 2. That's one valid way of doing it. I could have a shorthand of this, num plus equals 1, which would add another 1 to 1. I could have a plus plus num, which is another shorthand for adding something to num. And I could also have num plus plus, which is a shorthand for adding something to num. Now, what's the difference between these last two? I mentioned them earlier, but I didn't really tell you the difference between them. And also, just to make it clear, you could have num minus minus. You could have minus minus num. You could have num minus equals 1. And you could have num equals num minus 1. So all of those are valid. Whether it's num minus minus or num plus plus, num minus minus obviously will subtract 1 from num, while num plus plus will add 1 to num. But I'm just going to focus on the initial ones. Okay. What is the difference though? Because those are the key ones, the two ones I want to talk about. What is the difference between plus plus num and num plus plus? So let me show you. Let's do an example. Okay. Let me just tell you first. This is prefix. It's pre the number. This is postfix. It's afterwards. What's the difference? The difference is depends when it's going to happen. If you're doing math in C++, it uses the regular operators, and there's an order of operations. This plus plus after the num is the last thing that's going to happen before the statement is done. This plus plus num will happen ahead of that. So if I say, let's set some A's, B's, and C's. If I say A is 2, comma, B is 3, and C. So now I have 3 variables. I'm going to say that C is equal to A times plus plus B. Now what is C going to be? Well, C is going to be plus plus B is going to happen first. That's going to add 1 to B, so it's going to be 4. And then A times 4 is going to be 8. So it's going to be 2 times 4. It's going to be 8 because plus plus B is an operator that will happen in that case. However, if I were to have it plus plus at the end after the b, and the spaces don't matter, but if I were to have the plus plus afterwards, this is what would happen. It would be 2 times 3, which is 6. 6 would be c. Then after all of that is done, once the assignment is done, then b is going to have something incremented. So in other words, it's the last thing to happen. Now, that is a little bit dangerous at times because it's the last thing to happen, but it's also something to take advantage of at times as well. But in this case, if I did, it would really be 2 times 3 is going to be c is 6, and then afterwards b would become 4. Okay, so let's see a while statement using a counter. Well, it's essentially the same thing as we did earlier, which is we could say total equals 0, and I'm going to say while I'm going to have a counter. I'm going to make these ints and stuff like that as well. That way we don't breach any protocol. Int counter. Okay, counter is just a good way to remember what we're doing. So int counter. So while counter is less than or equal to 10, as long as that's the case, I'm going to say total equals total plus counter. Okay, so counter is going to start at 0. I'll start it at start counter at 1, and total is going to do that. So let's see, and then I'm going to say counter plus plus. Okay, so here's what's going to happen. Counter is going to be start less than 10. It's already 1. So total is 0 plus counter is 1. It's going to give me the new total. It's going to be assigned to total. That's going to be 1. Counter plus plus will increment counter now. So now counter is 2. Go back to here. Is counter less than 10? Yes. Take total, which was assigned to be 1, add in 2 because counter is 2. 2 plus 1 is 3. Good. Counter plus plus. Now counter is 3. Now total was 3. Counter is 3. 6. Counter is 4, etc. What is this doing? It's adding 1 plus 2 plus 3 plus 4 plus 5 up until 10. So this is just a running total. It's a running sum. It's a simple way to do it, but I'm using this counter plus plus in order to increment. Okay. In this case, I could say plus plus counter really doesn't make any difference, but this is just a way that I'm incrementing. So we talked about incrementing and data validation. Now let's talk about another one, which is another use of a while statement is if we were to have a sentinel. What that means is if I were to say points does not equal -1. Okay, so let's just pretend we have whatever it is inside this while statement, whatever it's doing, and it's going to keep going around and around and around and around as long as points is not -1. So as long as this is a true statement, points is not -1, right? So for instance, let's say that you're giving me scores on a test. Okay, so I'm going to take points and I'm going to make that an int points, and I'm going to say I'm going to see in I'm going to set points equal to 0 just as an initial thing, and I'm going to have total. Okay, total is just going to be 0 as well, and let's make that into an int as well. And I'm going to say while points is not equal to -1. Okay, I'm going to see in points. I'm going to let you tell me how many points you got on the test. Right? I'm going to see in points. Now, let me do that actually at the end of this program, and you'll note why as we go. But for the first thing is, assuming that points is something, okay, while points is not -1, 0, so it's not -1. So while points is something, I'm going to say total equals total plus points, and we're going to do what we did before. We're adding it all together, okay? And we're going to say C in points, and I'm also going to increment, have a counter somewhere, which I didn't create yet, so I'm going to go back up here. I'm going to say int counter, and I'll set that equal to 0, okay? And I'm going to just have a counter plus plus. Okay, Counter, the reason I'm using counter is because I wanted to just keep track of how many times I'm doing this loop. So here's the idea. While points is not -1, which means that you just keep telling, now it starts as not -1, so it's true. It's going to be 0 plus 0 is 0. Fine, counter is now 1. But, okay, counter is now 1. We could actually, well, whatever. Let me start from -1, so that way it'll get to 0. Okay, so now counter is 0. C in points. You now tell me what points your points on the test are. I'm going count points is not -1 because you told me 83. Total plus points is 83. That's the total. Counter is now 1. Now counter now went from it was 0. Now it's going to go to 1. Okay, so counter is now 1. C in points. Give me another score. It's going to add points to total, and it's going to be the new total. Counter, it's going to be 2. Every time that you run this, okay, it's going to go. So let's say you gave me 2 scores. The first one is going to be here. Counter is going to increment to be 1. Second one is going to be here. Counter is going to increment to be 2. C in points. Now let's say the next time you give me -1 for points, while points is not -1, keep going. But if points is -1, stop. What that means is if you say that you put -1 in, that's the signal to say end the points counting. Okay, we're counting how many points you have. And then at the end, we're just going to take the average, and I'm going to say double average is going to be equal to points divided by counter, because counter is how many times we incremented. And so that's going to give us the total number of points averaged over the time, because counter was doing that for me. But what was the whole idea of this points not equal to 1? That is a sentinel. What that means to say is it's going to check it and assure us and say, well, if points is equal to -1, keep. If it's not equal to -1, keep going. If it is equal to -1, so if points is not equal to -1, this is true. Otherwise, it's false. If it is equal to -1, it's false. What that means is stop. That's the sentinel. You put in like -99, negative something. That's just going to be a stop. It's going to be wait. Oh, okay, got to stop because we hit that spot that we're good with. Okay. Now there's a couple small things that we could do that are so that's another. So we have counters, we have data validation, we have sentinels, and that's essentially the major points. With a while loop, you could also say something like while true. And you'd say, well, why would you do that? Because it's just going to be an infinite loop. Because if it's always true, then it's just going to be an infinite loop, and it's going to keep going on forever. And it's just going to do while true. It's just going to count it, do whatever it's supposed to do again and again and again and again. So the answer is that because you can actually break out of this if you need to. But the point being that while true is a valid argument. That's my point for now. Okay. There is a variation on a while loop called a do loop. Okay. A do loop, you could see that it actually has this whole syntax that it built for me. Do something, okay, while true. This I don't need, but do something while true. Now let me put in while x is less than 50 and x is greater than or equal to 1, the opposite, x is greater than 50, because I'm using an and, x is greater than 50, and x is less than or equal to 100. So I can put my condition at the end. Do something while this condition is true. What's the difference between a regular while statement and do while? The regular while statement may or may not execute the first time if the condition is false. But the do statement always executes the first time because it checks to see if the while is true at the end. Checks to see the condition afterwards. So it's going to always run once. So kind of like if you needed to put your name in, we wanted to do while, and then we check it to see if you gave us valid information. Okay. Now sometimes we want to say something like while input equals because we want to say it's the same as y. But we don't want to write or, there's your or, input equals little y. Why? Because there might be lots of things that you could have put. Okay. So one of the ways to get around having those or statements is to say to upper, and so you could say to upper. To upper is a method, and what it does is I could say little y little y is going to be equal to input. So I could say something, right? I could say 2 upper for little y or big Y or input or whatever it is, right? I could say 2 upper and 2 upper. Of course, there's a 2 lower as well. So input is going to be a char, let's say, char input. And let me write it correctly. And I have my while statement. So what I'm doing is I'm saying, I don't know what input is, and I don't know what y is, but I'm just going to assure myself that whatever I'm doing, that they're the same. Now, really, I could just write big Y. But the point is that 2 upper and 2 lower are perfectly valid ways to affix and assure the validity of the yeses and nos that you might be putting in. Okay, let's go for some examples now. Table of square roots. I'm going to throw this into main. Okay. Table of square roots. Let's see what this does. See out table of square roots end line. Int number equals 1. While number is less than 100, what are we going to do? If number is less than 100. If number is less than 10, see out blank. Okay? Because see out blank. See out number and then space square root. So if number is less than 10, then blank, because we're not going to do numbers less than 10. But once if this is the end of the if statement, right? Because there's no brackets around the if statement, so it's just that. See out number space square root of number. Okay, so let's say less than 10, so 11 or 10. So 10 is going to take the square root of 10. Okay, end line number plus plus. And that means we're going to go to 11, square root of 11, number plus plus. 12, square root of 12, number plus plus. This is going to be a table of square roots. It's going to go through all the square roots. If number is less than 10, in other words, which it is, in numbers 1, it's just going to put a blank. So it's going to have a couple blanks, and then it's going to say that. So this is a bunch of square roots, and this would be using a while function to list the square roots. Square root is a function in C++. Okay, there we go. Powers of 2, because we did table of square roots just then. Powers of 2. Let's make a list of our powers of 2. Okay, see out powers of 2 end line. Here's a table. Number is 0, power is 1. That's our starting point. While, and here's our condition. While see out number, power, okay, number is 0, power is 1. We're putting that out there. Number plus plus. Number now became, it was 0, now it's going to be 1. Power times equals 2. What does that mean? Power times equals 2. Power was 1, now it's going to be 2. So for your number 1, okay, so for your number 1, you're going to have powers of 2. 2 to the 1 is 1. Now we're going to increment it, so it's going to be 2. Now power is going to be times equal to, it's going to be 4. So 2 gets you 2 to the 2 is 4. Then it's going to be 3. So that's going to be times equal to, okay? So it's going to be 4 times 2 is 8. So 3 is going to be the power of 8. In other words, 2 to the 3 is 8, etc., etc. So here's our while loop, counting number many times, looping through it. Strongly suggest you code these and you run these and you write this down and you do it with me because it's the best way to learn. Okay, here's a tricky one, but really nice. Reverse digits of a number and save the result. Int n, int answer equals 0. Enter a number greater than 0, C and n. Good, that's the easy stuff. Enter a number greater than 0, C and n. If n is less than 0, then illegal, exit 1. Okay, so that's also the easy stuff, which is just double check the errors. Exit 1 is just going to exit the program. We're going to say illegal, we're done. Okay, here's the tough stuff. While n is greater than 0, what are we going to do? You put in n, all right? Answer is 0. So it's going to take answer, which is 0, and it's going to do it times 10, which now is nothing. So you entered a number greater than 0, right? But it's nothing. It's going to do n mod 10. So let's say you entered 71. 71 mod 10 is 1. It's going to take 0 plus 1. You're going to get a 1. That's going to be new answer. Answer is now 1. Okay, so now the last digit is now the first digit. because it was n mod 10. So 71 mod 10 is 1, because that's the remainder. So that's going to be saved as answer, because this is 0, because answer is originally 0, because we did it up here, and times 10, so you're going to get 1. N divided by 10. 71 divided by 10. This is integer division. What that means is that if there's no doubles here, what that means is that we're going to be just counting how many times it goes in, but chopping off what is essentially the last digit. Because 71 into 10 is going to chop off the remainder. So 71 into 10 goes in 7 times. We don't care that it's some point something, right? So 7 is going to be saved as n. Now, answer, okay, was 1. It's going to be times 10. So it's going to be 10 plus 7 mod 10, because 7 is n now. 7 mod 10 is 7, so it's going to save that as answer. Together, 10 plus 7 is 17. Answer, see out answer. Boom, we reverse the number. Let's try a different number. Let's try 3, 5, 2. Let's talk through this with 3, 5, 2. N is positive? Yes, we can keep going. Okay. If n is not positive, because you did, it's going to be 0. You're going to stop. Answer 0 times 10. So 3, 5, 2. N mod 10. Okay, what is 352 mod 10? Well, let's see. Mod 10 is going to say it's going to be 352 would divide in 35 times, but it's going to be 2 is the remainder. So 352, 2 is the remainder. So we're going to say 0 plus 2, answer is 2. N divided by 10 is going to be how many times n 352 goes into 10 without caring about the remainder, because it's integer division. 352 divided by 10 is 35. So we're going to get n is 35. Answer right now is 2. 2 times 10 is 20, plus n mod 10. 35 mod 10 is 5, so it's going to be 20 plus 5 is 25. That's the new answer, is 25. Then n, which was 35 mod 10, is going to do 35 divided by 10, rather. 35 divided by 10 is 3, because we don't care about the 5. Goes in because integer division. N is 5. So now answer, which was 25, which was, sorry, 25, is going to be times 10, so it's now going to be 250. And mod 10 is going to be 3, mod 10 is 3, so it's going to be 250 plus 1 is 3, so 352 became 253. And that's going to be answer. N is now going to be, n divided by 10 is going to be 0. 5 divided by 10 is 0. Because integer division is less than 1, you just do the integer, so n is not greater than 0, so it's going to stop. So what this does is it reverses the numbers. You should really work through this with a number, do each step out and trace it just like I did with you, okay? Trace every step. But this is a while loop that's going to go through it and reverse the number. Let's talk about a primality test. Prime test, enter an integer greater than 1, see an int, okay? You entered number, whatever. If number is less than 1, exit, okay. Trifactor equals 2. While trifactor is less than number, so if 2 is less than number, yeah, let's say you had 7. 2 is less than 7, good. If number mod, so 7 mod trifactor, 7 mod 2 is 0, is that equal to 0? Is that true? Is 7 mod 2 0? No, there's a remainder, so your number is not prime. So we can keep going, okay? There's no return, there's a return statement here, because if we ever get it to be not prime, then we can tell you what the factor is, but good, we're done. Trifactor plus plus. It was 2, now it's 3, okay? Because we have this while statement that's going to keep saying, okay, trifactor less than number. Is 3 less than number? Was 3 less than 7? Yes, okay. 3 number, which is 7 mod trifactor 3. 7 mod 3 has a remainder, so it is not 0, so skip this if statement, go to the next one. 7 mod 4, 7 mod 5, 7 mod 6, okay? Go up until it is less than it, so it's 7 mod 7, it's not going to do it. If we go all the way through, your number's prime. Done. Let's try the number 21 now, okay? Trifactor is 2, trifactor is 2 is going to be less than 21, yes. 21 mod 2, no, that's not prime, return 0. So don't do any of this if statement, go to trifactor is 3. 3 is less than number, less than 21. What about 21 mod 3? That is 0, so your number is not prime. It has a factor, which is trifactor, which is 3. Return 0, exit, get out of the program. This is a while statement. This is the whole while statement, and it loops around and around, checking the if. What's the if? If the remainder is 0. If you ever have a number that it has a divisor that with a remainder of 0, then it's not going to be prime. And we're taking that fact and using that to do a primality tester with a while loop that's going to test every possibility up until that point. So there we go with our while loop, and I want to erase this because it has an error with that return if it's not in main over there. So there we go with our while loop, and that's our introduction to while loops. Now I'm going to go forward. Let's see, this is stream insertion. Okay. With a for loop, and I will be doing for loops, doing a bunch of examples with for loops as well. Okay. I'm going to include it in this video too, because this is chapter 5. Maybe I'll break it up at a later point. We'll see. For loops now. Sorry about that. I'm just coughing, but there's a nice echo here. I'm drinking soda. I don't. Well, it's carbonation. A for loop is a really nice, powerful tool. It's just like a while loop, but it loops through something. So I'm going to say for. And I actually just press tab there, and I'm going to say int I equals 0, I less than or equal to 10, I plus plus, and this is the for loop. There's a surprising syntax. For this, do something. I is going to start at 0. I starts at 0, and it continues up until I is less than 10. So it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I is less than 10. I plus plus is what you're going to do to it. You're going to increment it once each time you go around. So I'm going to say something like int total equals 0, and I'm going to say and that's what I'm going to have. What I'm going to do now is I'm going to say total equals total plus I. Okay, so let's see, and then I'm going to see out each time total. Okay, so this is what this does, which is it's going to say total 0. For I is 0 up until I is less than 10, I plus plus. Keep going incrementing by 1. Total is total plus I. So total is initially going to be 0 because I is going to start at 0. I will actually let I start at 1, and I will let this go up until 20. Okay, less than or equal to 20. I'll do it less than or equal to because that's perfectly valid as well. Total equals total plus I. It's going to start at 1. Total is going to be 1. It's going to see out 1. Now I is going to be 2 because this says increment it after everything is said and done, which is not at the beginning of the for loop, but the increment after everything is said and done, because that's how the for loop works. Increment it afterwards, and so now it's going to be. So now we have CO total was 1. Now we're going to increment it, and I is going to be 2. Now is it less than or equal to 20? Yes. So therefore, do total plus I. 2 plus the original total, that's 3, output that. And then do 3, then increment I, 3 plus whatever total is, then 4 plus whatever total is, then 5 plus whatever total is, then 6 plus whatever total is, and increment all of those. It's going to output each one of those because this is a for loop. So let me run this. And let's clear that. I should probably say end line, so that way it'll be marginally intelligible. Okay, it says 1, 3, 6, 10, 15, 21, 28, 36, 45, etc. Those are the triangle numbers. That's how many dots you need to make a triangle. 1, then 3, then 6, then 10 as you get bigger and bigger. This is a loop that keeps a running total for us. This is a for loop. Now, what if we wanted to count only odd numbers? What if I just wanted to have a list of odd numbers? Or, in fact, I wanted to add together odd numbers. So rather than say int I equals 1, I less than or equal to 20, I'm going to actually say I is going to be incrementing by plus equals 2. I'm going to let I increment by 2 each time. Right? It doesn't have to be that it increments by 1. My I is going to increment by 2. Plus equals 2 is just going to be add 2 to it. So it's going to be 1, then 3, then 5, then 7. It's going to add all of those together, 1, 3 plus 3 plus 5 plus 7 plus etc. And I'm going to show you what that is as well. I don't know if you can see this so clearly, but you get the 1, 4, 9, 16, 25, which are the squares. If you add up the odd numbers, you get the squares. Okay, so those are the square numbers if we do it by 2. And if you can imagine, we could do it by 3. We will get the pentagonal numbers, and which are by 5. And so that's 1, 5, 12, 22, 35, 51, 70. Those are the pentagonal numbers. And you can keep going if you increment by more. But this is incrementing. Now, what if we wanted to go the other way? That's not an issue. We could have said I is equal to 20. We're going to start at 20. I'm just going to output I each time in this case as well, just to show you what it's going to look like. So I is going to be 20. And do it as long as I is greater than 0. And instead of saying I plus plus, because we're starting at 20, we're going to say I minus minus. So start at 20 and count down. Start at 20 and go as long as I is greater than 0 is true, keep going. What if it's not greater than 0? Then stop. So it's going to do I minus minus. It's going to do I is going to be 20, then 19, then 18, because I minus minus means it's going 1 less. And that's perfectly legal as well. 20 down to 1, because we have that 20 down to 1, and it's counting backwards because we're looping the other way. Okay. Now it's time to go and see a bunch of examples having to do with for loops. Okay, let's go see some. All right, for loops. Okay, in our for loops, we have, let's print the table of squares. We saw that. This is our for loop. But this is a slightly different way of doing it, where it's going to say for int number 1, number is 1, number less than or equal to 100, number plus plus. Do the loop of that. I'm really not liking this print, but I will make it bigger and hopefully it'll be okay. Do the loop of that. I want you to see out number, which is 1, and then the square, which is number times number. Okay? So you're doing this for loop. And it doesn't have any brackets, so it's just going to do the next line, but that's okay because that's all we want. For I int number equals 1, number less than 100, number plus plus, number space, number times number. Okay, let's do a column of stars. A column, okay, so C is going to stand for column. Int C is 1, C is less than 80, C plus plus. What are you going to see out? Star, just in there. That's going to be a star, and so it's going to do that 80 times. So it's going to be a column. Okay. This is the sum of odd numbers for a for loop. We did it slightly differently, which is fine. A square pattern. Okay. This is 2 for loops nested inside each other. R for row, C for column. So as you may expect, you could nest for loops as well when using them. So for int R is equal to 1, R less than 10, R plus plus. So you're going to do this. And then you're going to do C. As C is 1, C is less than or equal to 10, C plus plus. C out star. This for loop is going to run 10 times when you, let me say that again. When you're in the first row, the first R, the column is going to run 10 times. It's going to do C out, star, 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 star. So there's no end line here. So it's just going to do star, 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 star. So it's going to fill in for each column. This for loop runs 10 times in the inside. Then it finishes, and then it says next line. Go to the next row. Now this outer loop will run again. You're in the second row because R is now 2, and you're going to run this for loop. You're in the second row. You're going to run this for loop 10 times. Go across. Star, 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 star. It's going to give you a bunch of stars. Okay. So let me throw in. It's going to do this. It's going to run this for loop 10 times, and then it's going to go to the next line. Then it's going to be back in the outer loop, which is now R is going to be 3, the third row, and it's going to run this 10 times, etc. Okay. Let me show this to you in C++. This is our code, and I'm going to run it. Start without debugging, and we get star, 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 star. Now it looks not like it just because the spaces are different from length and width. and height, whatever, but that is a square, really. Okay, so we have a square pattern. We have one for loop inside the other. We do this for loop, and it's in the first row, and we do something in that whole row. Okay. Table of odd numbers for a for loop. We did something like that already. Okay. Odd sums nested for loop. Here's a for loop on the outside. Here's a for loop on the inside. Let's see, and then here's another for loop. Let's see what they all do. Okay. I and n are going to exist. For n is 1 less than 10. What are you going to do 10 times? You're going to do something 10 times. Odd is equal to 1. Okay. For I less than n, so I is going to be less than n. N is 1, I is also 1. Let's say we're at n is 3. So I is going to go 1, 2. Then and if n is 4, it's going to go 1, 2, 3. If n is 10, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I is going to be less than n always. This is perfectly legal. I is going to be less than n. See out odd, which is 1, then plus, and now do odd equals odd plus 2. It's going to be 1 plus 2 is going to be 3, and odd is now going to be 3. So you see out in a 1, and now you're going to have a plus, and that's just going to be the next spot, and you're going to have odd equals odd plus 2, so it's going to now be a 3. Okay. Now it's going to do this up until n times. So it's going to do 1. Then 1 plus, it's going to do it, let's say n is 3. Okay, so it's going to do it when I is 1, it's going to do this. Odd is going to increment. Then it's going to do it when I is 2, and odd is going to increment. Then it's going to do when I is 3, and odd is going to increment. Okay, so each time it's going to produce the next odd number as you go. All right, it's going to do this n times. Now we're going to say C out equals in sum, and we're going to do a for loop adding the sum plus the odd one for each odd, because odd is going to go up. So now we're going to actually do a for loop that's going to figure out what the sum is. You should really break this code down and look at it step by step. Okay, so let me run this and show you what it looks like, but it's essentially doing 2 different steps at the same time, 2 different steps. The first step is it's going to use this this for loop over here to list 1 plus, it's going to be 1 plus 3, then 1 plus 2 plus 5, then 1 plus 2 plus 5 plus 7. Because that's going to do it n times, it's going to be less than n. So if n is 10, it's going to be 1 plus 3 plus 5 is 10 plus 9, right? Then it's going to say equals, see out equals, and then it's going to tell you what it actually equals by summing it. Sum plus odd is going to be a running sum, and odd plus 2 is going to count that way. Okay. Once it did that, it's going to finish 1 plus 2 plus 5, and then we have this outer for loop, which n is going to go to the next n. So let's just see it, because it might help you to understand it if I just show you what it looks like. Pretty neat idea, though. It's a chart. It says 1 equals 1, 1 plus 3 equals 4, 1 plus 3 plus 5 equals 9, 1 plus 2 plus 5 plus 7 equals 16. And you can see, just like we had before, these are the square numbers. If you add together the next odd number, that's what it gives you. So spend some time thinking about this, because these loops are not super straightforward, what each one does, but I'm explaining to you for you to practice it and think about it and try this. See if you could code this yourself. See if you can get 1 equals 1, then 1 plus 3 equals 4, then 1 plus 3 plus 5 equals 9, etc. The idea being that you have one loop which outputs 1 plus 3, then 1 plus 3 plus 5, and 1 plus 3 plus 5 plus 7, etc. You have another loop which actually calculates it. Okay, pretty neat. Triangle pattern. I should probably just show this to you before I look through the code with you. Control C. Let's put this in here. And I'll run it just to show to you what it is. First, it creates a triangle, if you were wondering. How large do you want the triangle? I'm going to say, 20. There's a triangle, which is 1, and it's 20 on the bottom. Okay. Now, what's happening? Double for loop. Here we go. How large do you want your triangle size? It's r equals 1 up until r is less than or equal to size. Do it until as long as r is less than or equal to size, r plus plus. So we're going to do it for 1, then 2, then 3, then 4, up until whatever size is. But it's nice because it's dynamic, really. Okay. What are we going to do? We're going to say C1, C is less than or equal to R. So you're going to count. So let's say we're on R is 1. C is only going to go to 1. It's going to put a star. Now, it's going to go to the next line, N line. Okay, R is 2. So C is going to count 1, 2. It's going to put 2 stars there because it's going to put C out star. It's going to run through a loop, doing it once, then a second time because C is less than R, because R is, it's going to be 1, 2. Then go to the next line. R is going to be 3. C is going to start at 1. It's going to be less than or equal to 3. 1, 2, 3. And it's going to put out 3 stars. End line, go to the next line. Because this for loop doesn't have any brackets, so it's going to be just that. But each time the inner loop goes, it's going to count how many times it's less than R. So if I had R is 10, it's going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to put that many stars, and then go to the next line. Then go back to the outer loop and keep going and doing that. So this is a nested loop. Very, very worthwhile to try and look at it and understand it as best you can. Okay, you could look at these crazy things like arrow patterns and stuff like that, and sum of cubes and other things. I'm not going to get into right now. But this code is really neat. Print numbers with a digit sum, and I'm going to go through this with you right now. Control-C. Okay. You can do a lot if you haven't noticed. Once you have for loops and you have if statements, while loops, and for basically your iteration, and in if and switch are your logic, you can really do anything. The rest is just, organization and stuff. For int C equals 1, C less than 1,000. Okay, fine. C is less than 1,000. What are we going to do? Int digit sum is 0. Okay, presumably you were given, it's going to print all numbers between 1 and 1,000 with digit sum of 20. Okay, so that's what we're doing. We could print all, we could also just add any digit sum, but okay, that's easier. But all numbers between 1 and 1,000 with digit sum of 20. That's what we want to know. Digit sum is 20. Okay, so we're going to have to find the digit sum for all these numbers. So if C is 1 and it's going to keep going, this for loop starts here and it ends over here. So basically this whole program is in the for loop. All right, so it's going to do it for 1, then 2, then 3. It's going to check and see if it's digit sum of 20. If it is, it's going to output it. All right, digit sum is 0. Temp copy is C, and it's going to set this up at the beginning of each time it does the loop. While temp copy is greater than 0, okay, temp copy is C, so C is 1, then 2, then 3, then 4, etc. All right, so temp copy is going to be greater than 0. While that's true, which is always going to be true in this. Temp copy mod 10, let's say we're at 11. So it's going to be 11 mod 10 is 1. It's going to save that as last digit. So last digit is a 1. Then it's going to say digit sum plus equals last digit. Add a running sum, so add the last digit to there. Temp copy divided by 10. 11 divided by 10 is going to be 1. Temp copy is now that. In temp copy is greater than 0. And so it's going to do 1 mod 10, that's last digit, and then digit plus equals 10 is going to be 1 plus 1 is 2. Temp copy divided by 10 is 1 divided by 10 is 0, so temp copy is not greater than 0. Stop. If digit sum is equal to 20, see outside. No, 2 is not equal to 20, good, no. Let's try 326, okay? It's not equal to 20, but let's try it. Okay, because we're going to go through every C. Every C is going to do it. We're going to check every number. This for loop says check every number. Okay, let's say we're up to 320. Okay, temp copy is C, is going to be assigned C. So C from this thing is keep incrementing because of this. 326, that's what we're going to use. Okay, temp copy is greater than 0. Yes, 326 is greater than 0. All right, temp copy mod 10. That means that I'm going to take 326 and do mod 10. Now mod 10 means we're going to have 6. That's the last digit. Digit sum plus last digit is going to be 6 now. Temp copy divided by 10. 326 divided by 10 gets rid of the last digit, so it's 32. 32 equals temp copy 32. Yes? Okay. Temp copy mod 10. 32 mod 10 gets rid of the last digit, so it's going to say 2. It is the last digit, rather, 2. Last digit is 2. Now add it to digit sum. So before we had 6, now we're adding 2 to it, so we have 8. Then 32 divided by 10 is going to be 3, because it's integer division. Then 3 mod 10 is 3, and it's going to add 6 plus 2 plus 3 is going to be 9, 10, 11. And it's now temp copy is going to be 2 over 10, which is 0. And so temp copy is not greater than 0. Now, if digit sum equals 20, what was digit sum? It was 6, because we took out the last digit, then 2, because we got now, because the next digit, then 3, because the next digit, so it's going to be 11. Is digit sum equal to 20? No. So therefore, what? Keep going with your for loop. Don't see out it, just keep going. What this is going to do is print out every number which adds to 20, because we're asking if digit sum is equal to 20. And in case you were wondering, these are the numbers. There's 1, 2, 3, 4, 5, 6, 7. Okay, I'm not going to count them. But these are the numbers that have a digit sum of 20 between 1 and 1,000. And obviously you need, there's only 1 to 99, but there's going to be only 2 300s, a couple 400s, a couple more 500s, but as you get to the 8, 7, 8, and 900s, you're more likely to hit it because, the 9's contributing enough to get there. But that is our if statements and for loops and while loops all together. Doing this, you really gotta try, put a number in, run through each step, just like I'm talking through it with you. Put a number in, run through each step, see what's happening, talk it out, think it out, run it, play with it, see what happens in this beautiful code. Okay, now we're gonna finish up with doing files for storage. Okay. Files require us to import a library, which is the fstream. The fstream is the import library which we're going to need, just like we need iostream is going to be for C in and C out. Fstream is going to be for file streams, where we're going to input stuff. Okay, this program writes data to a file. The first thing you need to do is create the data type. So of stream, output file stream, is going to be an output file. The name of it, the variable name is output file, but the type is OF stream. Output file dot open. Take your OF stream and do a dot open demo file.txt. It's going to actually create that. If it's trying to write data to a file, it will actually create that file. So you might want to make sure that you're not overwriting anything and stuff like that. But for now, we're just going to create it. Output file.open demo file.txt. That's going to create this. Notice it's in quotations. Open is a function or method of the OF stream variable type that allows, I don't want to call it an object, but allows .open to create a file. All right, now cout, now writing data to the file. What's it going to do? You use the stream insertion operator, which is this, to say output file less than Bach, output file less than Beethoven, output file less than Mozart, output file less than Schubert. It's going to output those 4 names to the file. In other words, this text file will have Bach, next line Beethoven, next line Mozart, next line Schubert, done. Okay, you use the stream insertion operator, just like with C in and C out, you have these guys. Okay, now just like C out is that way, this is output file, it's out, it's going out. It's an output file stream, so you're going to use the stream insertion operator, and you're going to do that. And now you wrote to a file. You created a file with the dot open of, now this, here's first line, create it. Second line, open the file. Third line, output something to the file. That is going to output something to the file. Then just make sure to close it, output file.close. Notice the parentheses over here. The open is opening a specific type. The close knows which it's closing, so you don't need to tell it. But that is going to close it. And make sure you close it to the memory leaks and stuff like that. But here you go. You have an output file stream is going to do this, and this is going to be your really nice, is going to just, nice, straightforward way to do that. Let's now look at an example using the fstream operator to write user input to a file instead of what we did before, which we wrote data to a file, but let's write user input to a file. All right, so let's set it up. How do you set it up? OF stream output file and string name, because we're going to need both. Output file.open is going to open a file called friends. Presumably it doesn't exist. Otherwise, we might have issues writing things over. cout, enter the name of 3 friends. All right. So here's our for loop. Count equals 1, count is less than or equal to 3, count plus plus. It's going to count through 1 through 3, can enter 3 friends. Friend number count, number 1, in name. Give me the name. Output file, stream insertion operators, boom. That's going to take the name of your friend and put it into the output file. Output file is friends, and you're going to put the name in, then you're going to close it. So you don't have to just put something you write in. You can actually get user input to put it in. Okay, that was writing to a file. Here's reading to a file. So if we have the F stream that it can do, file stream, it can do just like in and out. We have input file stream and output file stream. So here is your IF stream, your input file stream, and this is going to be the, let's just call it the variable thingy, maybe object or something, right? That is of type IF stream, input file stream. You want to input something. Okay, just like before, you got to open the file. We already put your friends' names in there. Okay, but now it exists, so we could open it, no problem. For count equals 1 through 3, count plus plus, go to the next, the next, the next one, do it 3 times. What are you going to do? Input file greater than name, because this is input, just like cin. It's greater than, stream insertion operator. It's going to take the next name, whatever is in there, it's going to call name, because name is just a string. It's going to take the next string, and then cout name. It's going to do that. It's going to output it. So this is going to take the next string, and it's going to break it down. It depends on how you did it. It will break it down by spaces and stuff like that. This could get technical, of course, because there's lots of ways that you might want to chop up your data. And this is obviously just an introduction to it, but it's the way that you could look at it, which is input file greater than name is going to drag out from the friends.txt the names that you put in. It's going to take whatever you put in, it's going to call it name, it's going to do input file to it, which means it's going to read it, and then you can cout name, because name is going to be saved as the thing. And it's going to then be saved as the next name, the next name, the next name. Then, because we don't have memory leaks, input file let close. Okay. So we read to files with the we wrote to files with the OF stream, output file stream, and we read to files with the input file stream. All right, let's develop. Okay, IO stream, F stream. This program sums a numeric value stored in a file. Okay, we want to sum it. Okay, so how do we do it? We're going to have to read the file. That means file stream objects are going to be necessary. Input file stream, we're going to read the file. String file name, int values, double value total. Okay. Create everything on top over here. These are file stream objects. I was kind of avoiding that, but it says it, so I will say it too, whatever that means. And we have it. Cout, the program reads and sums the values of data. Enter the name of the data file to read. You tell me file name. Okay. What's file name? It's a string. You tell me the file name, whatever the file name is, okay? And let's say you actually specify the directory and stuff. How many values are stored in your file? Num values. How many times should I look through this, right? How many times should I look through this? So that's going to be num values. Input file, open. Which do we want to open? Whatever you told me to open. And it's a string. You don't need to say any more than that, because file name was a string, as you can see up there. So input file.open is going to take the input file stream object called input file, the input file input stream object called input file, and it's going to do it to file name. Now let's loop through it. Where do we want to loop up to? However many values you told me are in there. Num values. You told me num values. Count less than or equal to num values. Okay. Input file greater than value. It's going to assign value whatever the next data point is. And then it's going to say total plus equals value. It's going to add that together. And then it's going to output it. But this loop, this for loop, the neat thing is the for loop is going to go however many times you like, because it you told me what number to get up to. You told me which number to get up to. Okay, so this is going to loop through. It's going to open the file right there, and then it's going to loop through, reading from the file, saying value is the thing it's pulling out, and it's going to add that to total. And the next one is going to call value as well and add that to total. So here we are reading from the file and doing that. Now, I just want to show you what about certain cases, and this is really a neat thing. Where's the EOF in here? Okay. Everything is the same as before. This program reads files in a data file, sums the values in a data file, okay? So you give me the file name. Okay, here's the only difference, this line right here, okay? This is really neat because I would not have thought of this. Maybe you would have, but I find it neat. While input file is greater than greater than value, that's the stream insertion operator. While this is true, in other words, while it actually continues to read information from the file, because input file is the thing that allows it to read it, value is what it's going to be saved as. So if that's true, that it was able to read it, then num values plus plus, then there's going to be more values in there, and total equals total plus value, and whatever value was added to the total. Okay. But it's going to keep going. You don't have to tell it where to stop, like with the if statement, with the for loop before, how many values you had, because here it's going to do it automatically. It's going to go when the end of the file is, value is not going to be anything, so it's going to be while is false, and done. And it got the total. So what this does is it grabs value if there is one. If there isn't one, the while statement is false, and now it did it. So it's really doing two things in this while loop. It's grabbing it and assigning it to value, whatever the next data point is, and it's saying true or false about that. If it is something, then great, right? Because while 5, well, 5 is just 5, that's true, right? But if while false, because this is nothing, so then it's not going to work out. So this while loop, really think about this, this while loop is amazing because what it's doing is it's doing two things, which it's grabbing it, but it's also telling you true or false, because if there's nothing there, then there's nothing assigned to value, it's just going to be false. Because it tried to get something and didn't work out. So it's pretty neat that you can do that. Now I need to catch up on one thing with you. Boom, close these up. No, don't save anything. Don't mess my files up. Okay, let's catch up on one thing. What is the difference between a while loop, a do while loop, I'm not gonna write all those out, a while loop, a do while loop, and a for loop? Okay, well, a do while loop will run it at least once. A for loop and it doesn't have to, because it depends on what the story is. Like a while loop may just not run it. A while loop and a do while loop are infinite, assuming unless you give it a condition to stop, right? You could not give it a condition to stop. So you could say something like while true and do something, and it's going to keep going infinitely far. A for loop, it tells you when it begins and when it ends. Now you could write a for loop to be infinite as well. You could say for int I equals 0 and not specify anything in the when to stop section. Okay, I'm not going to specify anything in the when to stop section. I'm just going to say I is 0, I plus plus. I don't even have to say I plus plus. I could just say start at I is 0 and just keep going. Now that could also be an infinite loop. So in that sense, you could mess yourself over pretty well. But there are ways to break out of this. You could use a break statement. A break statement, wherever it hits the break statement, it's going to break out of the for loop or the while loop. So a break statement exits the loop. So if you're in an infinite loop, and let's say I said, give me your password, and I gave you it gave me an infinite number of tries to get it. If you got it, so then I could say break and then get out. Instead of saying while true, I could leave while true, just say, oh, just keep doing this infinitely far. However, if you got it, if something like if password equals whatever your password is, and I'm just going to say ABC, don't use that as a password ever. But if password equals whatever, then I'm just going to say break. And get you out of the loop. So that would be, you could actually well, I'm not going to talk about that, but in Java, I don't know if you can do in C++ also, there's something neat you can do. But if password is ABC, so then break, and then that way you can get out of this infinite loop. That would be one way to do it. You could also say continue, and continue is actually going to be a code word that allows you to skip everything below. In other words, it's going to say whatever you have below continue, skip and go back to the beginning of the while loop. So just skip everything and go back. So we'll see it in some code and examples, but now let's just focus again that I sidetracked you a bit about what's the difference in a for loop and a while loop. A while loop generally will be for something that's infinite. A while loop is when you don't know when it's going to end. A for loop is generally when you do know when it's going to end. When it has no preset ending, you'll generally use a while loop. When it has a preset ending, you'll generally use a for loop. Now, we saw cases where you could get around those two conventions, but that's generally the convention about when this happens. And that's that. That's chapter 5. I strongly suggest you go through the problems. There is a lot of review up, and I will be doing more review and videos by doing practice problems in the book. But that's the learning stage of chapter 5. Now we have to go to the practice stage of chapter 5. Okay, there we go. Let's close that.